So when we were looking at translating into symbolic form and our conditional statements, we were talking about the truth value of them. And we're going to now look at something called counterexamples that can help us figure out the truth value of a statement. So we are going to look at this learning target. I can determine that an argument is false using a counterexample. When we talk about a counterexample, that just means that it's an example that shows a conjecture is false. And a conjecture is another word for our statement, our conditional statements, anything like that. So what we're going to do with these statements is we are going to determine whether it is true or false. And if it's false, we're going to provide a counterexample. So it's just an example of why that statement is false. So if we look at the first one, the sum of any two consecutive integers is always odd. Now, consecutive means they're right next to each other. So when I'm listing out numbers, I have 1, 2, 3, 4, 5. So 4 and 5 are right next to each other, and that's an example. So when we do this, we can start just adding. So 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 4 is 7. 4 plus 5 is 9. So as we can see, that statement is true. For number 2, we have the product of two numbers is always larger than either number. Now, when we think about this, remember that we also have decimals and fractions that we can use. So if I think about some fractions, I can use 1/2. And if we do 2 times 1/2, that's 1. So that's not larger than either number because 1 is bigger than 1/2. So that's an example that proves it wrong. So this example right here, 2 times 1/2 equals 1, is my counterexample. It proved that that statement was false. Same thing about doing 0 times 5. Remember, any number times 0 is 0, and that's not larger than either number. So again, false. Number 3, we have the product of two perfect squares is always a perfect square. So remember, perfect squares are a number times itself. So you can do 9 times 16 or 16 times 25. In that case, we are going to get a true statement. So we're still doing examples to figure out whether they're true or false, but we're only writing down those examples when it is false. So we have our counterexample. Number 4, we have the area of a rectangle 6m squared. Then the dimensions must be 2 meters by 3 meters. Remember, area is found by length times width, so theirs does work. 2 times 3 is 6, but that's not the only way we can get this area. We can also get it by having 1 as a side and 6 as a side for our rectangle. So that, my 1 by 6 rectangle, is my counterexample that proves that this statement is false. That's just how we're going to do all of these. We can do a couple more examples. So number 5 says dividing by 2 always produces a number less than the original number. So when we think about this, if we look at our positive numbers, then we might think that that statement is true, but we also have our negative numbers. So remember, we have positive, negative, fractions, decimals. We have to think about all of these types of numbers when it just labels it as a number. If I look at that, then say I divide negative 8 by 2. Well, negative 8 divided by 2 is negative 4, and that's not less than the original number because negative numbers are sort of backwards, so negative 8 is smaller than negative 4. So that proves that this example is false, and this is my counterexample. For number 6, we have vertical angles are never complementary. Now remember, vertical angles are angles that are right across from each other with lines intersecting, and they are congruent. And then complementary angles equal 90 degrees. So if we think about two congruent angles that could be complementary, well, if both of them are 45 degrees, then that proves that this statement is false. Number 7, if A times B equals 0, then either A equals 0 or B equals 0. And we know that that's true because if we have the product of two numbers is 0, then one of them has to be 0. Number 8, two angles supplementary to the same angle must be congruent. And that statement is true. We can draw out pictures to help us with all of these types of angles. Pictures are a really good way to see if something works or not. Number 9, all state names have at least 2 syllables. So if you start thinking about the different types of states, the first example that came to my mind was Maine, and Maine is my counterexample that proves that this statement is false. The last one that we're going to look at is squaring a number and adding 1 will always produce an even number. So if we just start squaring some numbers, so you could do 2 squared or 5 squared, and those work right now. But if we look at 2 squared, well, 2 squared is 4. 4 adding 1 is 5. That's not an even number. You could also look at 10 squared. 10 squared is 100. 100 plus 1 is 101. So those different examples prove that this statement is false, and these are my counterexamples. We're going to be using counterexamples quite a bit throughout the unit just to determine the truth value of statements.